Okay, class, we're going to study today about solving two-step equations. And I'm going to show you how you can do it using a model representation here. Then we're going to go in the book and go through the examples. So if you can see this, hopefully you're able to see make it a little bit, zoom in just a little bit for you. Um, Okay, now you see the equation is 3x minus 2. So the green represents the x's and the little squares represent the variables or just some numbers without the x's. So you have 3x and the red is minus 2 equals, that's 4 squares. So the first step, you add to both sides because the object is you want the x's by itself in groups. So what they did is they added 2 to both sides. So what they did, they removed it, or they added the 2, and they moved this over to make it 6 because it was there. So we added a 2 to both sides. So you had 2 before, and now you have 2 more, 2, 4, 6. Okay, so you had 4 before. So now you have 6. I hope you follow me. Okay, simplify removing 0 pairs. So basically, you paired up the 3 with 2, the x with 2, and the x with another 2, and the x with another 2. So each x is 2. So x equals 2. Now this is just using the tile. I'm going to show you a different method where you can use it, solve equations um, mathematically through steps. But this is how you can visually see it. Okay, here's another one. Okay, 3x minus 2. So you have the 3x's here, and you have the red, which is the minus 2. Okay, so you want the 3x to be by itself, so you have to add the opposite to it. So you're going to add a positive 2 to both sides, which is here. Okay, so that zeroed that out. That's not there anymore. So you take the 2 that's added and combine it with what you have. So you have 2 more squares here. And so you see that each x is 5 squares. So therefore x is 5. Okay. And here is where you can see it done using not the tiles, but just the numbers, 3x plus 5. So first of all, you need to get the variable, which is the x, by itself. So you add an opposite, which is a negative 5, meaning zeros here. Now you have 3x equals 21. In order to get the x by itself, that means 3 times x is 21. Okay, so you want to know what x is. So through the operation we learned last week, whatever you do on one side, you do on the other, and the opposite of multiplication is division. So if you divide both sides by 3, dividing by 3 gives you 1x. So dividing by 3 gives you 7. So x is 7. Then, of course, you can check your work. And you know 3 times 7 is 21 plus 5 is 26. That's how you get your answer. And here's another sample. Oh, that's a t-chart where you have 3 times. See, first you says 3 times x, and you added 5 to it. You have to divide by 3 second, and then see the second step. So that t-chart may be a little confusing for you. So if you can follow either one of those, it'll be fine. So I'm not going to spend a lot of time going through the t-chart for you because I think this may help you a little more. If you have a question, I'll go over it in class. Okay? So we can take a moment and just look at the hands-on activity on page 530 in the textbook. So this is the equation here that we're modeling, 4x minus 2 equals 10. So you see here we have the 4x's and we have the red squares which represent minus 2. Okay, so step 1, you just modeled it. They set it up in a model. Step 2, Add how many tiles to each side of the mat to form 0 pairs on the left side. So of course we added the two tiles. Okay, so that's what happened here. So you see in this step 2, they plus 2 on both sides, which means we added 2 more to it to make it 12 on the right side. Okay, step 3, remove both 0 pairs from the left side so that the variable is by itself. So when they added the positive, that zeroed it out, so nothing's there. Put the variable, which is the 1, 2, 3, 4x equals 12. And step 4, divide the remaining tiles into how many equal groups? Looks like it's 4 equal groups. That, in essence, you're dividing by 4. So in each group, there's 3. So you see x is equal 3. So you have 4 times 3, 12, and 12 minus 2 is 10. So it checks out. Now let's go to page 533. And number 1, create or draw a bar diagram to represent this situation. The situation here is that a company charges $2 for each balloon in an arrangement and a $3 delivery fee. You have $9 to spend. How many balloons can you purchase? So I want you to draw a bar diagram to represent the situation. Then we're going to write an equation that is modeled by the bar diagram based on what we just talked about, where we have $2 per balloon is 2x plus something, the fee, equals how much you spent. And the next question, how can you use the bar diagram to determine the number of balloons you purchase? So take a moment to do that. So we can see this is a sample. You have balloons, you have 2x, and then you have the fee is $3, and then the whole thing is $9. You don't have to draw it like this. You could have drawn it with the tiles like I'd shown you earlier, which would have been 2 tiles and 3 squares equals 9 squares, you know. And so the equation that is modeled by the bar diagram is 2x plus 3 equals 9. And in the sample example, sample answer is we subtract 3 from the $9. I have $6 to spend on the balloons and divide by $2 cost per balloon so I can purchase 3 balloons. Okay? Let's look at example 1. You can see it's already been worked out, but let's review it. You have 2x plus 3 equals 9. That's the equation. You want to zero out the number that's added to the x. So if it's added, that means you add its opposite, the inverse of it. Additive inverse of a plus 3 is a minus 3, leaving it 2x equals 6. Then you have to do the opposite of multiplication, 2 times x, which is divide by 2, okay, to make this 1x equals 3. And of course, you can check your work. We can look at example 2. The same procedure. You can see that 7 is being subtracted. What's the opposite of subtraction? Addition. So we're adding 7 to both sides. And we see we must divide by a negative 2 because we want the y to be positive. So the solution is a negative 5. In example 3, it's mixed up as far as the variable is not at the beginning. The variable is second. Doesn't really matter. You're still going to add an opposite for the 4, and you're adding a negative 4. So you already have a negative 1 here, leaving 1/5 equals negative 5. So you know 1 over 5 is division, so you have to multiply by its reciprocal, which is 5. And if you multiply both sides by 5, and you have to multiply by a positive 5, okay? And you already have a negative 5 here. So positive times a negative is a negative 25. And in example 4, we see the real world problem that's represented is 2x plus 17 equals 23. So we add an opposite to the 17, and therefore we're subtracting the 23. We have to divide by 2 because you want the x by itself, and 2 is multiplied by x to get, it was the cost of each drink is $3. Now let's try to guide it and see if we can do that. You have 4x plus 5 equals 13. What's our first step? You're right, we're going to minus 5 on both sides. Right. So now we're going to zero that out, and we have now 4x equals what? If you subtract 5 from 13, what do you get? 8, right? So now we have to get the x by itself, so we're going to divide by 4. So did you get x is 2 for a? Let's try this. Minus 5a plus 8 equals negative 2. Of course, we have to take the opposite of the 8. Now we have both sides. So you have what you're adding two negatives. That's going to be a negative 10. So you have negative 5a equals negative 10. So we have to we want a positive a, so we got to divide by a negative 5, not a positive 5, because we know two negatives makes a positive. And so we see that a is going to leave us with a negative 2 as an answer. Okay, I misspoke. What was my mistake? It should be a positive 2, not a negative 2, because we are dividing by negative 5, and a negative into a negative is going to give a positive 2. Now we have the one with the fraction, but don't let it throw you off. We know we're going to add the 2 to both sides because we want to zero that out. So this will be a plus 2, leaving 2/3 W is what? 12. So now we're going to take the reciprocal. We want the W to be 1 by itself. So we're going to multiply by 3 over 2 on both sides, because that is the only way it's going to change to 1, because the reciprocal of 2/3 is 3 over 2. If you multiply that, that will give you 1W. So you have to do it on both sides. So let's try to remember how to multiply. We can multiply straight across, or we can put 12 over 1 and divide both sides by cross divide. And you 4 going to 4 one times, 4 going to 12 three times. And when we multiply, we get 9. And you can always check your work. If you would put 9 in for W and minus 2, would you get 10? Okay, it's getting really late for me. Again, I miscopied it. It should be 3 over 2, not 4. So I have 3 over 2 here. Okay, so, okay, I just made my correction. It should not have been a 4. 3 over 2, with it being 3 over 2, I can multiply straight across and get 36 over 2, which converts to 18. Or I could have divided 2 into 12 and get 6, and 3 times 6 is 18, same 18. So what we're going to do for homework, you're going to do the guided 1 through 4, page 536, and you can try the 1 through 6. You can stop at 6 on 537.